All right, we are going to talk about the law of cosines. Here's a problem where maybe you know the ship left port and it sailed 10 miles in one direction and then 8 miles in another, and you wonder how far is it from the port now? Okay, so this obviously isn't a right triangle. It's an oblique triangle. And what do we know? We know two sides, and we know the angle in between them. So in this case, can we use the law of sines? In this case, no, because in order to use the law of sines, you need an angle and the side across from it. And in this case, we don't have that situation, okay? We have a side, angle, side. So we are going to derive the law of cosines. All right, so let's take a look at this. So again, you're not going to have to derive this, but this is just in case you're interested. All right, suppose we have a generic triangle here, okay? Any triangle, it's an oblique triangle. I guess it could be right, but we know this angle, okay? So here's point A, point B, and point C. So first of all, let's look at this up here. We know that cosine of theta is adjacent over hypotenuse, okay? And we know that sine of theta is opposite over hypotenuse, right? And obviously this only works for right triangles. So we kind of extend this out and we say, well, let's call this x and let's call this y. And just like for any point, we're gonna, this point C is, we could say, is that b cosine theta, b sine theta, where b is the length of the radius, right? So this is we kind of have constructed these two variables, x and y, right? And we'll say, okay, well, x is b cosine theta and y is b sine theta. So you could pause this and think about that for just a minute if you need to. Okay, so if we call this x, we know this is c, so this is x minus c. This is y, and we know this side is a, right? All right, so let's look at this little right triangle here that we have created, and we can use the Pythagorean theorem and say a squared equals x minus c squared plus y squared. Well, I'm going to replace x with b cosine theta, and I'm going to replace y with b sine theta, right here. And then do all the multiplication. FOIL this out. And let's rearrange things. So we have a b cosine squared theta. I'm just going to move this over, plus b sine squared theta, plus c squared minus 2bc cosine theta. Right, so nothing fancy here. I just have multiplied things out and then rearranged the terms. And then this is a little bit tricky. I'm going to look at these first two terms, and I'm going to factor b squared out. So I have b squared times cosine squared theta plus sine squared theta. And what do we know that is? That is 1. All right, so here's what we're left with. A squared equals b squared plus c squared minus 2bc cosine theta. Okay, that is the law of sines, or sorry, law of cosines. So here, and it doesn't matter really what we call A, B, and C, okay? The trick is that this angle alpha is across from A, and beta is across from B, and gamma is across from C, okay? So whatever two sides we put here, we call A and B. The third one is the one that we have to have the angle for. Okay, so we'll practice identifying this in just a minute. So if you'll also, let's just like ignore these last terms here. A squared equals b squared plus c squared. Hey, wait, that looks familiar. That's the Pythagorean theorem, right? So if alpha is 90 degrees, what's cosine of 90? That's 0, right? So this last term would go away, and we just have the Pythagorean theorem. So this really is like a more general form of the Pythagorean theorem, okay? It's just if if alpha is 90, if the angle between the two sides is 90, then this term disappears. Not sure what happened there. Okay, and down here we have different forms. This is the exact same equation, just solved for cosine of alpha or beta or gamma. Okay, So if I think of it as an extended Pythagorean theorem, it's not that hard to remember this, right? We have a squared equals b squared plus c squared minus 2bc cosine of alpha, which is the angle across from A. Okay. All right, so let's just use this. Let's do some examples here. So here we have a triangle. We have this angle, and we know these two sides. Do we have any angle with a side across from it that we could use the law of sines for? We do not. Okay, we cannot use the law of sines for this triangle. We need that ratio, and we don't have it. So we're going to have to use the law of sines. We have side, angle, side, two sides and an angle in between them. Okay, this is one of the two cases where we use law of cosines. Okay, so what am I going to call, so my A, B, and C. Okay, so here's the trick. So the side across from this angle I'm going to call is my B squared. So that's equal to A squared plus C squared minus 2AC cosine of beta. So this is just a naming game, okay? The important thing is we have this relationship. We have this angle and the side across from it. Okay, the angle goes here, and that's the important side that goes by itself over here. The other two sides are indistinguishable, right? It's a squared plus c squared minus 2, this times this, cosine of the angle. Okay, so now we're just going to plug some stuff in. So let's see, a is 10, so 10 squared plus 12 squared minus 2 times 10 times 12 times cosine of the angle that we have. Okay, now we can pretty easily solve this, right? This is just going to be 100 plus 144, let's see, minus 240 times, let's see, cosine of 30 is square root of 3 over 2. So what's that? 244. If I divide this, it's 120. 120 times the square root of 3. And if we take the square root of that, b is going to be about 6.013. Does that seem like it makes sense? Sure. That seems like about the right, order of magnitude for this triangle. Okay, let's do another one. What about this situation? All we know are the three sides of a triangle, and we want to find the angles. Side A is 20, side B is 25, and side C is 18. So let's draw this. A is 20, B is 25, and C is 18. Do we have any angles with a side across from it to use the law of sines? We do not. So this is the other case. If we just have three sides, we have to use the law of cosines. Okay, so in this case, it does not matter which side we choose to be A, B, and C. Let's just choose this one. Let's solve for angle beta. Okay, so we'll have b squared equals a squared plus c squared minus 2ac cosine of beta. So 25 squared equals 20 squared plus 18 squared minus 2 times 20 times 18 times cosine of beta. All right, so this is different than the last case in that here's our variable, right? We're finding the cosine of that. So, okay, I'm actually going to get my calculator out here. 25 squared, 625 equals 400 plus 18 squared is 324. And 2 times 20 times 18 is 720 times cosine of beta. All right, so 625 minus 400 minus 324 is minus 99 equals minus 720 cosine of beta. So minus 99 divided by negative 720 I get 0.1375 equals cosine of beta, and I can solve, let's see. Oops, typed it in wrong. The inverse cosine tells me that beta equals 82.1 degrees. Do I believe this? Yeah, that makes sense. Do I have to think about a different case? Well, let's think. Cosine, inverse cosine tells me is unique between 0 and 180 degrees. So that's one of the nice things about the law of cosines. We don't have any ambiguous cases. There's only one solution to this equation, and it's like, somewhere like there. We don't have to find a second case or anything like that. Oops, let me move this so there's morning sun coming in. Okay, so now we know our beta is 82.1. What do we do now? Well, now we have options. Now we could use the law of sines, or we could use the law of cosines again. To find, like, we could use the law of cosines for this angle. Let's use the law of cosines just for practice, but we could use the law of sines, right? Because now we have an angle and a side across from it. We could use the law of sines to find another angle. Totally legit. But since we're practicing the law of cosines, let's practice the law of cosines. So let's find this angle alpha. Okay, so in this case, we're going to have a squared equals b squared plus c squared minus 2bc times cosine of alpha. Right? So I'm choosing A to be my special angle or my special side over here because it's across from this angle alpha that I'm going to be solving for. All right, so now I can plug everything in. All right, so I'm going to just kind of put this in my calculator without walking through every step. Oops. So I get 0.61 equals cosine of alpha. If you're working along at home, see if you get that same thing. And then inverse cosine of 0.61, I get that alpha equals 52.41. Again, sure, I believe that. And now I know this angle, I know this angle. So I can subtract that from 180 and solve for my other angle, 45.49. Right, just using the triangle thumb theorem. So I solved for my three angles. Okay, let's do one more here. Let's go back to that. Well, let's do this one. Okay, on many cell phones with GPS, an approximate location can be given before the GPS signal is received. This is accomplished through a process called triangulation, which works by using the distances from two known points. Suppose there are two cell phone towers within range of a cell phone. So looks like we've got three things here. We've got a triangle. So here's one cell phone tower, and they're located 6,000 feet apart along a straight highway running east to west, and the cell phone, is north of the highway. We'll just flip this over. Based on the signal delay, it can be determined that the signal is 5,050 feet from the first tower and 24,020 feet from the second tower. Determine this, so we have to imagine this is flipped up. Well, okay, let's just draw a correct diagram here, guys. Let's not be lazy. This is 6,000 feet. This is 5,050, and this is 2420. Okay. Determine the position of the cell phone north and east of the first tower, and determine how far it is from the highway. So they basically want us to find this, and this, and this. right? Yeah. Determine the position of the cell phone north and east of the first tower. Okay. All right, so if we want to find this distance, we kind of need to find this angle here, right? So let's find that using the law of cosines. So I'm going to say, we're going to call this alpha. So I'm going to say 2420 squared equals 5050 squared plus 6000 squared minus 2 times 5050 times 6000 times cosine of alpha. All right, and I'm going to plug this in to my calculator. All right, and I get that like it's about 0.9183 is cosine of alpha. So I get that alpha is 23.33. So how am I going to find this and this? Well, now I use my trig ratios, right? I'm going to say, let's see, sine of alpha equals, let's call this x, equals x over 5050. So sine of alpha times 5050 is 1999.7. So I'm just going to say about 2000. Okay, so it's about 2,000 feet north of the highway, if this is our cell phone. And what else did it want? The position of the cell phone north and east. So if we also want to find this distance here, we're going to use cosine, right? Cosine of alpha is x, well, and let's call this, I don't know, a. These are not very well called variables, well-named variables. So 5050 times cosine of alpha is about 4,637 feet. Okay, so in this case, it wasn't like immediately obvious we had to use the law of cosines, right? We had a side triangle, but the question they were asking us, this light is really making this hard to look at. The question they were asking us is to solve for this, right? But in order to solve for that height, it was helpful. We needed to know this angle here. So that's why we had to use the law of cosines. Okay. All right, one last example. Let's go back to our ship that we started with. I'll just turn this around. How far is this ship from port? Well, we have the situation, we have side, angle, side, easy to use law of cosines. We just want to solve for this side here. So I'm going to call that x and say x squared equals 8 squared plus 10 squared minus 2 times 8 times 10 times cosine. Let's see, if this angle here is 20 degrees, this angle here must be 160 degrees, right? Because together they'll be 180. Sorry about this, son. Okay, so now this is just a matter of putting this in my calculator, right? 8 squared plus 10 squared minus 2 times 8 times 10 times cosine of 160. So x squared is 314.35. So the square root of that is about 17.73 miles. Does that make sense? Yeah. This is 10 and that's 8. The distance could be 17. I believe it. Okay, so that's the law of cosines. Really, it's just really that one equation. Looks complicated at first, but when you practice using it, not too bad. All right, so that's really all your homework is solving problems like that, either side angle side or side 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 triangles to find missing pieces of triangles.